Hello, welcome to the video session. So now this video session is mainly to show the problems or how to solve the problems on sections of solids. So now here in this video I want to show a problem that is hexagonal pyramid, solid hexagonal pyramid, side of base 40 mm and axis 80 mm long, standing with its base on HP such that its base sides are parallel to VP. That is the position of the object. A section plane perpendicular to VP and parallel to HP cuts the axis of a pyramid at a distance of 30 mm from the base. Draw the sectional top view and sectional front view. So that is the problem given. So now it is object is hexagonal pyramid, side of base is 40 mm, standing with its base on HP. Standing with its base on HP means the true shape is obtained in top view, that is axis is perpendicular to HP. So in this position, so we have to draw the hexagonal pyramid. So true shape is in top view. So side is 40 mm and base side is parallel to HP. So using stencil, a template, you can draw or you can construct the hexagonal pyramid, true shape 40 mm. So 40 mm, 40, so 40, 40, 40 and 40. So now, so the hexagonal, the top view of the hexagonal pyramid. So now join all these points. So first side, already you know the construction, but I am showing here. Here I have taken the bigger size so that you can clearly see the points and lines. So this is top view. Now mark the notations. Let me take here notations from here: A, B, C, D, E and F. This is O. Now I have to join the corners also. Corners. All the corners are joined. Now project these points up to the reference line. So let me draw the reference line. So this is the XY line at convenient distance. So this is reference line, XY line at convenient distance. So now above the reference line, VP, below the reference line, that is HP. So now top view is in HP. Good. Now draw the projections upward, up to the reference line only, because it is a pyramid. So up to the XY line, reference line. Now mark the notations here. So now looking from the front, which are visible here: A dash visible, B dash visible, C dash visible. Sorry, this is not C. So this is C dash, D dash, E dash, F dash. So these are the visible edges. Now on the axis line, take the height. How much height here it is? 80 mm. So mark the point 80 mm. Now join all these edges with the vertex. So now all these are joined. So now this is the vertex point O dash. Okay. Now this is the construction of pentagonal, hexagonal pyramid resting with its base on HP such that base edge is parallel to the VP. Okay. So now the second part of the problem is a section plane perpendicular to VP and parallel to HP. Perpendicular to VP and parallel to HP. That means The section plane can be seen in the front view, and which cuts the axis at a distance of 30 mm from the base. So on the axis line at a distance of 30 mm, mark the point P. Mark the point P. And to this point, a section plane is passing. That is parallel to HP means that is parallel to XY line. Parallel to XY line. So now this is the section plane. So see how to draw the section plane. Edges thick, in middle thin means similar to axis line. So this is you have to mark it as VT because section plane is in VP, therefore it is VT. So now this section plane you are marking here. So now this section plane is cutting the various slant sides, slant edges, that is O dash A dash number 1, O dash B dash number 2, O dash C dash number 3, O dash D dash number 4, O dash E dash number 5, O dash F dash, that is number 6. This is just point P, okay, just point P. Now after removing the portion, cut portion, this is the remaining portion. This is remaining portion. Make a thick lines. And inside the object you can make thick also. And yes. So this is the sectional front view. Sectional front view. Now I want to draw the sectional top view. For that, project the projectors from 1 downwards up to which is on O dash A dash, up to O dash A dash. Similarly, from 2 which is on O dash B dash, draw the projector, perpendicular projector up to O dash B dash. Similarly, from 3 it is on O dash C dash up to C. Then number 4 which is on O dash and D dash, project it up to number 4. Similarly, number 5 it coincides, it also coincides. Number 6 also coincides. Now these are the points here. So that is OA on OA 1, OB number 2, OC number 3, OD number 4, OE number 5, OF number 6. So now join all these edges in order. Here 1 to 2, then 2 to 3, 2 to 4, now the remaining portion in top, the remains of this slant sides, make thick line. The top portion is removed. After sectioning, the top portion is removed and this is the bottom portion. Now you have to draw the hatchet lines. This is section piece, you have to draw the hatchet lines. So angle should be 45 degrees. So for only one line, you take angle, then draw the parallel lines. That's enough. So now for only first line, I am taking angle. Right. Then maintain 2 to 3 mm gap. Not exact measurement, approximately 2 to 3 mm measurement, but all these lines parallel to each other. But if you are using drafter, you have to draw all these lines using drafter only. But here I am not using drafter, I am drawing these hatched lines using a scale. Okay, but all these lines should be thin, not too thin, little thin compared to the thickness of the edge. Thickness of the edge. That is section portion. Now this is sectional top view. You can write here sectional top view. This is sectional front view. Now we have to show the dimensioning. So here, so section plane is passing at a distance of 30 mm. So 30 mm from the base. Then what is the height? Height. How much height it is? 80 mm. 80 mm is the height. And what is the side of base? How much you have to take? 40 mm. 40 mm. So that's it. So that's the hexagonal pyramid. After sectioning, before and after sectioning, only remaining portion should be make thick lines. Okay, I hope you have understood this. And so these lines make thick line. Okay, so that is hexagonal pyramid. Then in continuation, for practicing you can practice any number of problems. You can practice. So prism pyramids, so square pyramid, triangular pyramid, rectangular pyramid, pentagonal pyramid, hexagonal pyramid, cone, anything, any objects you can practice. So now I am showing another example, a pentagonal pyramid, side of base 30 mm and axis 60 mm, resting with its base on HP, such that base edge is perpendicular to VP. Okay, then a section plane perpendicular to VP and parallel to HP cuts the axis of the pyramid at a distance of 35 mm from the base. Sometimes from the top, from the base, from midpoint. So that will change. Draw the sectional top view and front view. This is the problem. So object is pentagonal pyramid, side is 30 mm. Okay, to save the time, I have already constructed it. Just I am explaining. Already you know it also. So using template, so construct the pentagon such that one of its base side is perpendicular. In that position, construct the pentagon using the template. Then take 30 mm is the side. Then join all the corners with the midpoint in the top view. Draw the project the midpoint axis line, axis point. Okay, upward. On this axis line, take the height as a 60 mm. Project all the edges up to the reference line, XY. Then join the lines. So now that is the front view and the top view for the position of the object. Pentagonal pyramid, side 30, axis 60, resting with its base on HP. That is true shape in the top view only, and base side is perpendicular. If base side is parallel, it will change. Already know it. Now it is cut by a section plane parallel to HP and perpendicular to VP. Parallel to HP, perpendicular to V means the sectional plane will be in VP. So what is the height given? 35. On the axis line, always on the axis line, take the point at 35 mm distance, mark it as a P, and draw the section plane which is parallel to the XY line. Parallel to ground means parallel to XY line. Now this is how to draw the section plane. Now this section plane is cuts the pyramid at various points. That is, before that notations, all those things already you know it. So ABCD I have marked like this, looking from front, A dash visible, E dash visible, D dash visible, C dash not visible, B dash not visible, according to this notations. Okay, you can change, you can draw in any order. According to that only you have to show hidden and visible. Now at 35 mm we have drawn the section plane. So this section plane cuts the pyramid at various points. that is O dash and A dash number 1, O dash is E dash according to this, E dash number 2, O dash D dash number 3, O dash C dash number 4, and O dash B dash, that is number 5. Number 4 and number 4 and number 5 are in brackets. Now we have to draw the projections from these points. This point up to the lines, slant lines which is connecting the corner with the center. So from 1 up to O dash A dash, from 2 O dash E dash, number 3 O dash D dash, number 4 it is coinciding with the 2 only up to O dash C dash, number 5 coinciding with the line, projecting line from 1, so up to number 5. So now these are the points 1, 2, 3, 4, 5. So join, make a thick lines, and the remaining portion make thick lines, and this is the sectioned portion. It has to be shown by you taking by the hatched lines which are at inclination of 45 degrees. Okay, like this the practice pentagonal pyramid. Similarly, so another problem, that is right circular cone of base diameter 40 mm and height 60 mm, rest with its base on HP, that is the position of the object, and a section plane parallel to HP and perpendicular to VP bisects the cone, bisects. So in previous problems distance, here it is bisect. Draw the sectional views of the remaining portion of the cone, right. So now it is resting base on HP means true shape is obtained in the top view. Draw the axis lines. So using compass, and diameter is 40 means radius 20 mm radius. So draw the circle, then divide the circle into 8 equal parts because diameter is 40 mm, 8 equal parts. Then mark the notations A, B, C, D, E, F, G, H. Then draw the XY line, reference line. Then first project the center, that is axis line. Then project the projectors from all these points on the circle division. Okay, that is A, B, C, D, E, F, G, H up to the reference line. Now, so O dash is at a height of 60 mm. Join all the lines. Only outer lines thick, inner lines are very, very thin. That is how to draw the front, top view and front view for the cone when it is resting with its base on HP. Right. Now a section plane is parallel to HP, perpendicular to VP. That means you can see the section plane in the VP, and here it is bisecting. Bisecting means you have to take midpoint. Bisecting means making the piece into two equal parts. So on this axis line, take the midpoint, that is total is 60 mm, take 30 mm, mark it as P. Now draw the section plane that is parallel to the XY line. Now you know how to draw the XY line, this section plane. Then mark it as VP. Okay. After drawing this section plane cuts the cone at various points. That is number 1, that is O dash A dash. Number 2, O dash B dash. Number 3, O dash C dash. Number 4, O dash D dash. Number 5, O dash E dash. Number 6, O dash F dash. Number 7, O dash G dash. Number 8, O dash and H dash. Okay, so here you have taken 8 equal parts, that means you will get 8 points. In pentagon having 5 sides, you are getting 5 points. In hexagon you are getting 6 faces, you are getting 6 points, like that. So now from these points, similar to the previous problems, draw the projectors downwards, so that they will meet the end generator. Now this is number 1, which is passing through the OA. Number 2, OB. Number 3, OC. But here I will tell you the procedure. For 3 I will tell you. Then O4, O5, O6, O8, O7, O8. So listen here carefully. So okay, for cone, especially for cone, so for marking the point on the axis line, so take this P as center, and on the section plane touching the end generator as radius, and center O in the top view, draw two arcs up and down. Those points will be 3 and 7. After marking the points 1, 2, 3, 4, 5, 6, 7, 8, draw a smooth curve that will be exactly a circle. If all your constructions are perfect, you will get exact circle. But in cone, no need to join the slant edges, because it is a round face, no edges, all those are imaginary edges. Only for pyramids it is necessary. Okay, so these three problems you practice it, and if you are interested you can practice other problems also on square pyramid or triangular pyramid, rectangular pyramid, like that. Any number of problems you can practice. I hope you have understood this.